Hello Year 9s and welcome back to Mathemagic. In today's lesson we're continuing with our topic of properties of geometric figures, and we're actually having a look at quadrilaterals and polygons. Now last lesson you went through finding the missing angles on parallel lines. What we're doing today is actually looking at quadrilaterals, so four-sided shape, and polygons, so shapes with multiple angles. So here, let's just quickly talk about what we're dealing with. What we want to be able to do by the end of today's lesson is to be able to find missing angles in quadrilaterals and polygons, and we want to be able to identify the angle sum of a quadrilateral, find missing angles in quadrilaterals, identify the angle sum formula for polygons, and apply the polygon angle sum formula to find missing angles. So let's get into it. First of all, let's just quickly talk about the angle sum. Now, 2 lessons ago, we looked at the angle sum of a triangle, and I gave you this quick definition. I'm just going to make it a little bit more formal here. The angle sum of a shape is the result of adding together all of the interior angles of the 2D shape. So no matter what shape you have, when you add up all the angles inside your shape, it's going to add up to a number. And for all shapes with the same number of sides, it's going to be the same number. So for example, we looked at a triangle and we noticed that the angle sum for a triangle was 180 degrees. So when we added together all 3 of the angles inside my triangle, it always gave me 180 degrees, no matter what my triangle looked like. What we're going to do today is actually extend this and look at what the angle sum is for different shapes. And in particular, we're looking at a thing called polygons. Now, polygon is just a mathematical word, which means shape. Let me just put this here. So this just means shape with many angles or sides. So basically any type of shape, and the way that we name these shapes is based on the number of sides that they have. And so for example, we talked about a triangle, and if you remember from last lesson when we talked about the triangle, when we add up the angles inside my triangle, it's always going to equal to 180. Now here I'm actually going to do this in a particular way. What we're going to do is we're going to firstly, to actually identify what the angle sum is for different polygons, we're going to actually first of all identify the shape. Notice how many sides our shape has, and then from there identify how many triangles in the shape and what the angle sum is. Now the triangle part is just how many triangles can you fit in this shape that don't overlap, and you don't want and you also want all the angles of our triangles to be on the exterior of the shape. So I'm going to show you what that looks like in a moment. So first one here, a triangle. Now if you remember, a triangle has 3 sides, and here if we want to try and fit as many triangles as we can into our triangle without overlapping, we can actually only fit 1. There's only 1 triangle we can fit here. So for a triangle, there's 1 triangle, and so the angle sum is just going to be one lot of 180 degrees, or 180 degrees. We looked at that last 2 lessons ago. When we add up all the angles inside a triangle, it's going to equal to 180 degrees. Okay. Let's have a look at the next polygon. Now, polygons are named by the number of sides, and so here the next one is called a quadrilateral. Now, if we were following polygon notation, we'd actually call this a tetragon, but we don't actually call that very often. Now, a quadrilateral has 4 sides. Hopefully you can notice that. 1, 2, 3, 4. And if I wanted to fit in triangles into the shape, if you have a look, I can fit in 2 triangles. I have 1 here and 1 here. And notice here, all the angles of my 2 triangles are on where the angles would be for my quadrilateral. And so here, there's 2 triangles. And so what I'm going to do is, if I want to find the angle sum of my of my quadrilateral, well, because there's 2 triangles, I just need to do 2 lots of, so let me write here, 2 times 180 degrees. And 2 lots of 180 degrees will give me 360 degrees. Okay, so that's for a quadrilateral. So no matter what quadrilateral you get, the angle sum of every single quadrilateral is going to be 360 degrees. Let's do it for the next one. The next one is a pentagon. Now, a pentagon has 5 sides, and hopefully you guys can see that. 1, 2, 3, 4, 5 here. Okay, and we want to figure out how many triangles are in this shape. Now here, with a pentagon, I can fit in 1 triangle over here. I can draw another triangle in between here, 2, I can fit a 3rd one there. And here the important thing is I made sure that all the angles of all of my triangles happen to be where the angles are of my pentagon, the interior angles of my pentagon. And so for a pentagon, we can fit 3 triangles. And so here for our pentagon, if we want to find the angle sum of a pentagon, all we need to do is just 3 lots of 180 degrees. And so this will give me 540 degrees. So if I wanted to find the angle, when I add up all the angles inside any pentagon, any 5-sided shape, it will always give me 540. Okay, let's do the next one. And hopefully you're starting to see a pattern here starting to emerge. And now a hexagon. A hexagon has 6 sides. We've got 1, 2, 3, 4, 5, 6. Now once again, if we were trying to fit how many triangles there are, we can actually fit in one triangle over here. I can split up here and then fit in a second triangle. I can fit in a third triangle and a fourth triangle. So 1, 2, 3, 4. We can fit in 4 triangles. And so if I want to find the angle sum of a hexagon, that's just 4 lots of 180 degrees, because each triangle is just 180 degrees. And so that is going to be 720 degrees. Okay, now you might be wondering, so why are we doing this? Why are we counting how many triangles there are? The counting of the triangles is actually there so we can actually hopefully identify a pattern. Now notice, for all of my shapes, I've got a triangle which has 3 sides, a quadrilateral which has 4 sides, pentagon 5 sides, hexagon 6 sides. And if you have a look at the number of triangles that we can fit in them, notice there's a pattern here. Well, the number of triangles is just however many sides I have minus 2. Notice here, if I want to get from 3 to 1, all I need to do is just subtract 2. If I want to get from 4 sides of my quadrilateral to the number of triangles we can fit in the shape, we minus 2. If I want to get from the 5 sides of my pentagon to the number of triangles of 3, we minus 2. And this is actually a really nifty pattern that we notice about all polygons. So no matter what your polygon is, no matter what multi-angle, multi-shape shape you have, multi-side shape you have, this pattern is always going to emerge. And so if we want to find the angle sum of a polygon, this is what the pattern is going to be. So here I'm going to give you this formula. S is equal to the angle. So S I have here on the left hand side, that's for the angle sum. The angle sum of any polygon is just 180 degrees times, I'm going to put this in brackets, n minus 2. Now n here just represents the number of sides for our polygon. So notice here, for all of my shapes, what I did was, oh, hang on, I need to go back. Okay, so what I'm going to do, what we're going to notice here is that all of my shapes here, the number of sides is, when I want to find how many triangles fits in, all I need to do is just subtract by 2. So I subtract by 2, and then I take that number and then I multiply it by 180, and that gives me the angle sum of my polygon. So let's go and apply this formula. What we want to do when we're applying this formula is just find how many sides our number of sides our shape has, and then subtract it by 2 and then multiply it by 180. So that's what this formula tells me, 180 times n minus 2. Okay, let's use the angle sum formula to actually find the angle sum for a few different shapes. So using the angle sum formula, S is equal to 180 bracket n minus 2, so that's the same thing. That's just, we don't write the multiplication symbol here. Find the angle sum for the following shapes. Okay, so let's have a look here. Heptagon. Now a heptagon has 7 sides. So if I was to apply this formula, all it would be is just this angle sum is going to be 180 degrees times 7 minus 2. Because the number of sides is 7, and I'm just replacing n in my formula with 7. And so with our regular BODMAS, what we do is we do the subtraction inside my brackets first. And so that's going to be 180 degrees times 7 minus 2 is 5. 180 times 5 is actually going to give me 900 degrees. Okay, so if we want to find the angle sum, so the sum of all the angles inside these particular shapes, all we need to do is just figure out how many sides our shape has, subtract it by 2, and then times that number by 180. Let's have a look at the next one. A nonagon. Now a nonagon just has 9 sides. So here, n is going to be equal to 9. And so what I'm going to do is I'm going to write S is equal to 180 degrees. The angle sum is equal to 180 degrees times by 9 minus 2. So that's going to be 180 degrees times 9 minus 2 is 7. And so if you put this in a calculator, if you're not sure how to do this, you can always chuck this in a calculator. So I go 180 times, and I can put it as 9 minus 2. And that'll give me 1,260 degrees. 1,260 degrees. So it tells me for any 9-sided shape, any nonagon, if I add up all the angles inside that shape, it will always give me 1,260. Okay, last one here, dodecagon. A dodecagon has 12 sides, and so here all I'm going to do is the exact same thing. S is equal to 180 degrees times dodecagon has 12 sides minus 2, and so that's going to be 180 times 12 minus 2 is 10, and so that gives me 1800 degrees. So that's how we can find the angle sum of any polygon, any multi-sided shape. All we need to do is just figure out how many sides our shape has, and then subtract it by 2, and then multiply that number by 180. And that's what we did here to find the angle sum. Now we're going to use this a little bit later on in this lesson, but what we're going to focus on now is actually using angle sums to find missing angles. Now if you remember from a couple of lessons ago, we went through these steps. If we want to find any missing angles inside our shape, what we want to do is firstly identify the known angles inside the shape. So they tell us a few known angles. Then what we want to do is write out an angle sum statement. So for our shape, what we want to do is know what the angle sum is, and then write out that angle sum statement. So for example, we want to add up all the angles inside our shape together, and let's say it's equal to 180 degrees, or in this case it was a triangle, and then we just want to write that statement. Then what we want to do is subtract the known angles from the angle sum. And so we went through that a couple lessons ago when we were looking at the angle sum of a triangle. These steps are still going to apply for no matter what polygon you're going to look at. If you're trying to find missing angles in a polygon, these steps are still going to apply. So let's go and have apply this. And in particular, we're going to have a look at quadrilaterals. Now here, missing angles in quadrilaterals, the angle sum of a quadrilateral. Earlier in this lesson, we actually talked about this pattern that we noticed, and all the colors went away, and I'm very sad about it, but that's okay. With a quadrilateral, when a quadrilateral has 4 sides, and because it has 4 sides, there are 2 triangles that we can fit in it. And so no matter what quadrilateral you have, the angle sum is always going to be 360 degrees. And so when I add up all the angles inside my quadrilateral, it's always going to add up to, so A plus B plus C plus D. So if you have a look at this quadrilateral, it's got 4 sides, 1, 2, 3, 4. And we've got 4 angles in there, A, B, C, and D. When I add up all those angles inside my quadrilateral, any 4-sided shape, it's always going to equal to 360 degrees. And so we can use this to help us find missing angles. So let's have a look at this example. Find the value of the pronumeral in the following quadrilaterals, giving your reasons. So if you have a look, we've got a shape here. It's got 4 sides, 1, 2, 3, 4. And so what that tells me is that because it's a quadrilateral, when I add up all the angles together, it will always give me 360 degrees. So I can actually write an angle sum equation. So what I'm going to do is I'm going to add up all the angles here. So if you have a look, I've got x, 110, 80, and 100. And so what I'm going to do is I'm just going to write x plus 100 plus 80 plus 110. And that is going to equal to 360 because that is the angle sum of a quadrilateral. So I'm going to write here angle, that's just the shorthand for angle sum of quadrilateral, and I'm going to shorthand it to quad just to make it easier to write. So here this symbol just means angle, and the quad at the end here just means, it's just short for quadrilateral. And so whenever I add up all the angles inside a quadrilateral, a 4-sided shape, it's always going to equal to 360 degrees. Now, if you remember from last lesson when we looked at triangles, what I usually like to do here is I like to add up all of these angles here first. And so here what I'm going to do is I've got x plus 100 plus 80 plus 110 is actually going to give me 290. And that's equal to 360. And then the final step that I need to do is just move this 290 over to the other side and just subtract it. So here it's a plus on this side. When I move it to the other side, it becomes a minus. And so this just becomes x is equal to 360 degrees minus 290. And so that tells me that x is 70 degrees. So that's how we can find missing angles in our quadrilateral. First of all, we identify the angle sum. So here it's a quadrilateral. The angle sum is 360. I wrote out my angle sum equation. So I added up all the angles here. And because it's a quadrilateral, it's equal to 360. And then we started solving it using our algebraic skills. Okay, so that's this first example with quadrilaterals. Now, with quadrilaterals, there's actually a few special quadrilaterals that have special properties that we need to keep an eye out for. So here I've actually identified 3 quadrilaterals we're going to talk about. So here, these are special quadrilaterals and their angle properties. So let's have a look at this first one, a kite. Now, a kite is a shape, and here I've actually highlighted the thing that makes a kite a kite. If you have a look, we've got two sides that have exactly the same length over here. So these two sides are right next to each other. They're adjacent sides. They're right next to each other. And on the other two, these two also have equal length. So a kite has two pairs of equal adjacent side lengths. And so here, with a kite, these two angles over here that I've highlighted, what we're going to notice is that these opposite angles of kite are equal. So this angle at the top here is going to have the same size as this one here. And so if I have a kite, I can actually use this property to identify some of the angles that I might be missing in my shape. Okay, so that's the first special property we want to be aware of. If I have a kite, the two opposite angles where the two where the two pairs of sides meet. So for example, this side, and then because those two have the same length, and this side, it's where these two pairs meet. Those two angles that are opposite each other will be equal. Okay, the next one is a trapezium. Now, a trapezium has one pair of parallel sides, and that's what these arrows tell me. Now, the special thing about trapeziums is that because they've got parallel sides, just like we looked at last lesson, all our stuff that we know about parallel sides can actually apply to a trapezium. And so here, I've actually identified these two angles here. If you have a look at the shape that they form this C shape. And so that is actually a co-interior angle. So if you ever see a trapezium and you see those parallel lines, that means that you can use co-interior angles to find those two angles. Co-interior angles on parallel lines. And so here, let's say this side is A and this side is B. Co-interior angles just means that when I add these two together, A plus B, that's going to equal to 180 degrees. So co-interior angles, they add up to 180 degrees. And that's for trapeziums. Now, I've actually got an additional note here. What's the note say? The note says, note, this property will also apply for the following shape. So if we have a parallelogram or a rhombus. So a parallelogram and a rhombus, I'll draw them out here. This is what a parallelogram looks like. And these two sides are equal, and these two sides are equal. And a rhombus, all the sides are equal, and we've got two pairs of parallel sides again. This property will actually apply for parallelograms and rhombuses as well. So here, notice I've got a pair of parallel sides, and so I can form that C shape as well, and I can actually use my co-interior angles. And similarly here, with a rhombus, I can do the exact same thing. So this property will also apply for parallelograms and rhombuses. So this property for trapeziums will also apply for that. Now there's one more special property that we have, and this is for a parallelogram and also for rhombuses. Parallelograms have two pairs of parallel sides. So here I've got this side is parallel to this side, and this side is parallel to this side. The special thing about parallelograms, and this comes from the fact that we've got two pairs of parallel sides, is that the opposite angles of parallelograms are equal as well. And so here, this angle is going to be the same size as this angle down here. So these three special properties are actually quite useful for us if we want to find missing angles in a few of our quadrilaterals as well. So let's go through an example of this. So what we want to do with these is just identify the shape and any special angle properties, and then apply the angle sum if required. So let's have a look. This is example 2b. Find the value of the pronumerals in the following quadrilaterals, giving a reason. So let's have a look at the first one. Now, if you have a look at this shape, we've got 60 degrees. I've got 40 degrees. I have this unknown angle here of S, but if you have a look down at the bottom here, I've got this unlabeled angle. I don't have an angle, and so I can't just use the angle sum immediately. What we can do is we can firstly identify the shape. Now, if you have a look at this shape, we've got a pair of equal sides here, and I've got another pair of equal sides over here. And so based on the shapes I gave you above, this is actually a kite. And the thing about a kite is that the opposite angles, the angles where the two pairs of equal sides meet, they are going to be equal. So if you have a look, that angle is up here at S and down here at this unlabeled side. So what this tells me is that this angle down at the bottom, that's also going to be S degrees. So I use the fact that this is a kite to help me figure out that the unlabeled angle inside my quadrilateral is going to be S as well. And so now that I've done that, I can use the angle sum of a quadrilateral. So here, once again, it's a quadrilateral. 1, 2, 3, 4. 4 sides. And I can use that to help me find this missing angle. So let's have a look at, let's go and do this. So what I'm going to do is I'm going to write out that angle equation. So I'm going to add up all the angles. So I've got S, I've got another S plus 40 plus 60. That's going to equal to, well, because this is a quadrilateral, that's going to be equal to 360 degrees. And this is because of the angle sum of a quadrilateral. Okay, and just like we did in the last example, I'm just going to add up all the numbers on the left-hand side first. So here, I'm going to have 40 plus 60. That's going to be 100. Now on the over here, I've got S plus S. Now when we have S plus S, if you remember from algebra, they are like terms, and I'm just going to add them together. I'm going to have 2 lots of S. 2S is equal to 100. Okay. Now from here, I can move that 100 over and subtract it. And so here I get 2S is equal to 360 minus 100. And so that's going to give me 260 degrees. And the final thing here is I've got 2 lots of S, 2S. And so if I want to get rid of that 2, I need to divide both sides by 2. And so here, S is going to be equal to 260 divided by 2 is 130 degrees. And so that's how we can find the missing angle in here. We had to use the angle property that kites have of opposite angles being equal. And then we use that to help us find the missing angles here. Okay, let's have a look at the next example. Next example over here. I've got this shape here, and we've got these 2 angles Y and 125. Now, if you have a look, we don't get given anything about the other 2 angles. But that's actually okay, because if you ever look at the shape, what type of shape is this? Well, we've got 1 pair of parallel sides, which means that this is a trapezium. And because we've got those parallel sides, what this means is actually I can use my knowledge of angles on parallel sides to help me figure out what Y and 100. What Y is equal to. Now, if you have a look, this Y and 125 degrees makes a C shape. So that is going to be a co-interior angle. So what this tells me is that I have Y plus 125 is actually going to equal to 180 degrees because these are co-interior angles on parallel lines. So that's my reason. These are actually co-interior angles, and so we can form this angle relationship. When I add these 2 angles together, it's going to be equal to 180. And so here, Y is equal to, I'm going to move this plus 225 over to the other side. So it's going to be 180 degrees minus 125. And so Y is going to equal to 55 degrees. So that's how we can find the angles in quadrilaterals. So this last one wasn't actually related to the angle sum at all, but we could use some of those angle properties that we have about quadrilaterals. So with quadrilaterals, the main thing, most of the times you're going to be needing to use this angle relationship. When I add up all the angles inside a quadrilateral, it's always going to give me 360 degrees. Okay, final thing. Now that we've talked about quadrilaterals, we're going to go back to what we talked about earlier in this lesson of polygons. And so here we can also apply this finding missing angles for polygons as well. And the way that we do this is we want to actually we have to figure out what the angle sum of the polygon is first. So we want to use the formula, S is equal to 180 times n minus 2 first. And then after we figured out the angle sum, then we can write an angle sum formula, equation. So let's have a look at this following example. Here we go. For the following polygons, find the angle sum first by using S is equal to 180 times n minus 2 and find the value of the missing pronumerals. Okay, so in this example, let's have a look at what we have here. We've got this shape and we've got all these angles in here. We've got A, we've got 40, we've got 135, we've got 100, we've got 115, and we've got this right angle over here. So that means that this guy over here is 90 degrees. Now, we can't just use our angle sum of our quadrilateral because this isn't a quadrilateral. Let's figure out what type of shape it is. So we've got 1 side, 2 sides, 3 sides, 4 sides, 5 sides, 6 sides. We've got 6 sides. And so this is actually a hexagon. So what we need to do first is we need to find the angle sum of a hexagon. So let's do that. Angle sum of a hexagon is going to be S is equal to 180 degrees times n minus 2. And so that's going to be 180 degrees times, well, we've got 6 sides in my hexagon. So the 6 sides, I'm going to do 6 minus 2, and I need to put the brackets there. And so that's going to be 180 degrees times 6 minus 2 is 4. And so this is going to actually give me 720 degrees. So what this tells me is when I add up all these angles, it's going to equal to 720 degrees because this shape is a hexagon. So once I've done that, what I'm going to do is I'm just going to write my angle equation just like we did before. So we're going to add up all the angles inside my shape and then say, okay, that is going to equal to 720 because that's the angle sum of a hexagon. So I'm going to write them all down. So A plus 40 plus 135 plus 100 plus 115 plus 90, that's going to be equal to 720 degrees because this is my angle sum of hexagon. Okay, so I've written out my angle sum equation. What I'm going to do, just like we did before, is we're going to add all these numbers together just to make it easier for me. So I can actually chuck this in my calculator. So 40 plus 135 plus 100 plus 115 plus 90. So that actually gives me 480. So that tells me that A plus 480 is equal to 720. And just like we did before, we're going to move this 480 to the other side and subtract it. And so here, A is going to be equal to 720 minus 480. And so A is going to equal to 720 minus that answer, 240 degrees. So here, if we have a polygon which isn't a triangle or a quadrilateral where we know the angle sum, what we need to do first is we need to identify the angle sum. So we got to use this angle sum formula to help me find what the angle sum is for my given shape. Then once I've done that, then I do the exact same step. I write an angle sum equation like this. So I write down all of my angles, I add them up together, and it has to be equal to the angle sum I found earlier. And then once I do that, I've used my solving steps like I normally do with these angle equations. Okay, let's have a look at one more example. Now here, in this particular example, we don't have very many angles. We've just got A and B. But there's something actually very important to notice here. So I'm going to actually point something out. If you have a look at the shape, what type of shape do we have here? Well, I've got 1, 2, 3, 4, 5, 6, 7, and over here there's 8. We've got 8 sides. So this is n is equal to 8. This is actually called an octagon. Now the other thing that you notice, if you have a look at the shape, there's something else that's happening with the shape. Well, if you have a look at all the sides, we have a dash through all this sides, which means that all of these sides are equal. Now, this particular type of polygon has a special name. If all the sides of your polygon are equal, that means that that is a regular polygon. So a regular polygon has all sides equal, which is what those dashed red lines tell you. So all the sides are equal, which is what the red line, all the dashed lines tell you. And because of that, all the angles will be equal. All angles equal. Let me just write it like that. All angles equal. And so if we want to find the angle inside a regular polygon, all we need to do is just divide the angle sum by however many angles there are. So let's actually have a go at this. So firstly, I need to actually find the angle sum of my octagon. So I'm going to use this formula, 180 times n minus 2. So it's going to be 180 times 8 minus 2. 8 minus 2 is just 6, so this is 180 times 6, which I believe will give you, let's put this in our calculator, 180 times 6, I think it's going to be 1080 degrees. Okay, so that tells me that when I add up all the angles inside my octagon, it's going to equal to 180 degrees. Now, because it's a regular octagon, that means that each one of my angles are going to be equal. And so I can actually split up my 180 into however many angles there are. So there's one angle over here, 2, 3, 4, 5, 6, 7, 8. There's actually 8 angles inside my octagon. And so therefore, if I want to find B, all I need to do is just take my 180 and divide it by 8. And so this is actually going to give me 135 degrees. So let's just check that. Divide that by 8. It'll give me 135 degrees. So B is just going to be 135 degrees because this is a regular polygon. Then from there, I'm going to actually need to find out what the value of A is. Now A, if you remember from earlier in this topic, when we were trying to find missing angles, for example, A and B form a special relationship. They are angles on a straight line. And so what this tells me is A plus B is going to equal to 180 degrees because they are angles on a straight line. they're on the same straight line, and so they're going to add up to 180 degrees. And so A plus 135 is equal to 180. So A is going to equal to 180 minus 135, and so that's going to give me 45 degrees. So that's how we can find missing angles in polygons. Now, this section is quite long and difficult, so if you need to go back and have a look at any particular section, you can. And just if you need any particular extra help, let me know and send me an email to do so. So that's how we find missing angles in polygons and quadrilaterals. Hopefully that was helpful, and that's it for today's lesson year 9s. As always, I'll hope you guys are staying safe wherever you are, and I'll see you in the next video. Bye!